Hey everybody, today we're back with another problem, which is given that n is a natural number which is greater than or equal to 2, prove this inequality. And it is really long and it looks really difficult, and it is, but it's a really interesting question and I really want you guys to try it, so pause this video and give this problem a go. Okay. So if you found the answer and if you managed to prove this, then great job. It was a really tricky problem. If you didn't, that's also okay. It was a tricky problem when I first solved it, so I'm going to run through the solution with you. So many of you may have been wondering, where should I start, right? Because we see that we have factorials, we have natural logs, we have the inequality symbol, we have this condition n is a natural number greater than or equal to 2. Where do we start? Well, first, let's start by taking another inequality. Let's start by taking k is less than x is less than k plus 1. And this is where k is a natural number. So that's basically saying, well, maybe 2 is less than x is less than 3. Maybe 7 is less than x is less than 8, stuff like that. And why did we take this, you might ask? Well, it's actually the main foundation which we're going to put our natural logs. And we're also going to add a little bit of submission into this because, well, you'll see in a bit. So we have this k is less than x is less than k plus 1. What do we do next? Well, let's take the natural log of all of these functions, let's say. So that's basically saying natural log of k is less than natural log of x is less than natural log of k plus 1. Now that we got this, let's try taking the integral. And the reason I took natural log is because you see in the inequality we have to prove there are natural logs over here, here, and here. So we have to introduce that natural log. Next, let's try taking the integrand of this. So let's take it from k to k plus 1 because we see that x is greater than k and less than k plus 1. So let's just start from there. So integration k to k plus 1 of natural log of k dx, we're going to differentiate with x. And then integration k to k plus 1, natural log of x dx, once again differentiating by x, is less than integration k to k plus 1, natural log of k plus 1 dx, once again differentiating from x. Now, what do we do? Well, let's simplify this. Since we know that, let's start from over here. Since we know that natural log of k, is k, we have k here and we have an x here. This can be treated as a constant since basically it's in terms of k, not x, right? So we can just take that as a constant. So if we do that, we get natural log of k integration k to k plus 1 of dx. Here it's just 1. Here, let's leave this as it is for now. So we get k plus 1. I'm just rewriting it. And then here, same exact thing. This is k plus 1, but we are differentiating with respect to x. So we can treat this as a constant since there is no x in here. So we can just say natural log of k plus 1, integration k to k plus 1 dx. There's a 1 over here. Let's further simplify this. This is basically saying natural log of k of x, k to k plus 1. Once again, leaving this as it is. We will come back to this later. Doing the same thing here. I'm just solving this integrand. That's exactly what I did over here. I'm just solving the integrand of k plus 1 of x, k plus 1. There we go. Now we can just simply solve it. So we get natural log of k. This is k plus 1 minus k, so that's just 1. And 1 times natural log of k is simply natural log of k. So I'm just going to write natural log of k. is less than, this is once again same thing, k plus 1 natural log of x dx is less than, let me just move this to the side, is less than, once again, let's just simplify, natural log of k plus 1. This is basically saying k plus 1 minus k, which is just 1. 1 times k plus, natural log of k plus 1 is just natural log of k plus 1, so I left it like this. Now, okay, we're kind of getting there. We see we have a natural log k plus 1. We see that there's an n plus 1 here, so we're kind of getting there. We have the natural log part down, so that's really good. But we run into another problem. What about this factorial? That's a key component, right? Well, actually, now it's time to take the summation. So let's take the summation of k equals 1 to n minus 1, and you'll see why soon. And we're going to take this of natural k is less than, once again, the summation of this, k plus 1, natural log of x dx, summation of, oh, here it's k1, n minus 1, k equals 1. And remember, k is that natural number we said before in this inequality, just to refresh your mind. And then this is n minus 1 of natural log k plus 1. And yeah. Now okay, another page. Now what do we do? Well, since we have this, we can't really do anything now, like in terms of, yes, we can solve this integrand, but we'll leave it as it is, and you will see why now. So let's try to simplify this. We see that we have this, and we have this. So let's take this first. We see that k is 1, and it goes till n minus 1. So let's replace k. We get natural log of 1 plus natural log of 2, since we're setting k equal to 2. Then let's set k equal to 3 plus natural log of 3. Actually, let me do it over here. Plus natural log of 3. Then let's set it to 4. So basically what I'm doing, I'm saying at this point k is equal to 1, then k is equal to 2, k is equal to 3, then k is equal to 4. And it goes all the way till k is equal to n minus 1. So when k is equal to n minus 1, so this is when k is n minus 1, we can simplify this. We know that natural log of 1 is simply 0, so basically all of this stays. 2 plus natural log of 3 plus natural log of 4 plus natural log of n minus 1. Now, if you see a relationship, we know that basically a factorial is basically, we know that n factorial is n times n minus 1 times n minus 2 all the way to 3 times 2 times 1. So for example, if we have 5 factorial, that's basically saying 5 times 4 times 3 times 2 times 1. And then we just solve it. This is the exact same thing. That's exactly what we're doing over here. We see that we have this natural log n minus 1, and then we end at 2. And we also have a natural log of 1. So I'll just write it so that I can show you guys how we arrived to that factorial. So we see that over here, this is actually just n minus 1 factorial, because we're getting n minus 1. We're going to have an n minus 2 here somewhere, and then we're going to go from 4, 3, 2, and 1. And for those of you who are still a little confused, remember that these are all being added. And we know that natural log of alpha, let's say, plus natural log of beta is equal to a natural log of alpha beta. That is one of the properties of logs. So, that being said, natural log of 1 plus natural log of 2 plus natural log of 3, ongoing, is just natural log of 1 times 2 times 3 times 4 times n minus 1. And that is just n minus 1 factorial. That is how we get this n minus 1 factorial. And this is a big step because now we have introduced our factorial. But once again, we only solved this part. We also have to solve this part and this part. So let's do that. Let's say, let me get another color here. So this is 1. This is 1. Let's say this is 2 and this is 3. Now let's solve this. So we do the same exact thing. Let's get this color. We have this. Let me just copy this. We have this. Now let's start to solve it. We have summation k equals 1 to n minus 1, integration k to k plus 1, natural log of x dx. So, once again, we have a k here and we have a k plus 1 here. We can start replacing them. Let's say k equals 1. We get 1 to 2, natural log of x dx. Remember, we don't replace a 1 or a 2 or any number for x because we're replacing it for k, not for x. Then we're going to do k is equal to 2, so 2 to 3, natural log of x. This is when k is equal to 1. This is k is equal to 2. This is when k is equal to 3. Natural log of x dx. And now let's do when k is equal to n minus 1. So k equals n minus 1. Integration of n minus 1, n minus 1 plus 1, which is just n, natural log of x dx. Now we have expanded this whole thing, right? Now let's see for a relationship. We see that we have integration 1 to 2, integration 2 to 3, and we see that we're all integrating the same thing, natural log of x, natural log of x. So then this would essentially be equal to integration 1 to n of this natural log of x, because that's basically the same thing as its expanded form. For example, if you have integration 2 to 7 of natural log of x dx, you could write that as 2 to 3 natural log of x dx plus 3 to 4 natural log of x dx, all the way to until you reach the upper bound 7. It's the exact same thing. So let me just quickly erase this. Now that we have this, let's simplify it. So integrating this, I hope you all know the, what's it called? The rule that we use to integrate this. And what we're going to do, we're going to use integration by parts. There it is, integration by parts. So we're going to do integration by parts. 1 to n, x derivative natural log of x. And we're just going to solve it using integration by parts. If you don't know integration by parts, feel free to see my other videos. I go over how to do integration by parts, and it will really help when you're trying to solve this problem and prove the inequality we had in our question. So now we have 1 to n. We're going to do x, natural log of x, to 1n, minus integration 1 to n, x times the derivative of natural log of x, which is just x dx. This is just 1, so let's replace this. N, natural log of n, minus natural log of 1, minus n minus 1, n ln n. This is just 0, minus n plus 1. I just expanded this. And yeah, that's basically what it's equal to. So then this is our second equation that matched over here. Let's label this the main equation. And now we have to solve this one. So let me copy this once again so we can solve it. There we go. This, how do we solve this? Well, it's the same thing that we did up here with the first summation. So once again, we're going to replace k with 1, 2, 3, and then n minus 1. So we get integration natural log of 2, because when k is 1, we get 1 plus 1, which is 2. Oh, there is no integrand. Whoops. Plus natural log of 3, when k equals to 2. When k equals to 3, we get natural log of 4. Dot, 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 plus k is equal to n minus 1. Natural log of n minus 1 plus 1 is just n. And now we see why we put this n minus 1. Because that way we're getting a lot of factorials, and we get, once again, this is equal to natural log of n factorial. Once again, this is the exact same procedure we did with this, except this time it was k plus 1 instead of just k, but overall it's the same procedure. So now this is the third one. So we got all our values for this whole thing. Let me just circle it because this is really going to come in handy. Now let's just replace them. So let's replace, actually let me erase all of this. We know that, we know that this over here is equal to this, so I'm just going to write that. Natural log of n minus 1 factorial is less than this 2, and for 2, we got this whole thing. And natural log of n minus n plus 1 is less than, for 3, we got natural log of n factorial. Natural log of n factorial. And let's just erase this since we don't need it anymore. Now let's try to solve this. So let's take these two for a moment. Okay, this is a really critical point. So if we're taking these two, let's add natural log of n to both sides, because if you compare it with our question, we see that we have this, which is the left hand side, and then we also have this natural log of n factorial, which is in the middle. So we're just missing this, technically, and this, right? We don't know why this is here, but let's address that. Let's add natural log of n to both sides. So if we do that, we get natural log of n minus 1 factorial plus natural log of n is less than n natural log of n minus n plus 1 plus natural log of n. This, once again, we discussed that formula that natural log of alpha plus natural log of beta is equal to natural log of alpha times beta. So if we do that, we get natural log of n minus 1 factorial times n. And that's basically just n factorial. So we can erase that and write n factorial is less than, let's take the natural log n out of both of these terms. So we get n plus 1 natural log of n minus n plus 1. And then if we go over here, let's compare these two. If we write it the same, let's write it as it is. Let's write it the same. So we get n natural log of n minus n plus 1 is less than natural log of n factorial. Now, comparing these, we have a natural log of n factorial here and a natural log of n factorial here. Here we see that this natural log of n factorial is greater than something, and here we see that it's less than something. So let's put natural log of n factorial here. And we know that n factorial from here, it's greater than this thing. So let's write n natural log of n minus 1 plus 1. And we know the natural log of n factorial is less than this. So let's write this over here, n plus 1, natural log of n minus n plus 1. And what do you know? This is exactly what we had to prove right up here. That's exactly what we had to prove. So the main takeaway from all of this was, I believe, that this was the most critical point, as well as the summation. Because without this summation, because without this summation, for example, we wouldn't have gotten that factorial. But don't make the common mistake of assuming, well, if I take the summation of anything, I'm just going to get that factorial. No. This was a special case where if you take the summation, you are going to simplify to get a factorial, but it's not true for all of the time for all of the submissions, right? So yeah, if you figure this out on your own, great job. If you didn't and you needed a little bit of help, that's also perfectly fine. I know when I did it, I was stuck for like a lot of days. And yeah, so that is how you prove this whole inequality. And I'll see you guys next time. Bye.